Okay, this is Unit 4 lesson, or Unit 5 lesson 5.4, our final matching. So, when we're going to match equations, there's multiple different strategies we use. The first strategy we're going to use is to always look for the start point. So the first one is start point locate on y-axis. The y-axis, if you forget, he's the up-down one. He's the guy that goes up and down. So that's one way to match them. Okay? What if your start points are all the same? Well, here's the second way. If all start points are identical, you must look at the pattern number, which is also called the slope, which is equal to m now in our equation. So we've got y equals mx plus b. That's what I'm talking about right there. And we know that the b1 is the start point. Okay, he's called the y-intercept. Where he crosses that y line. That's what that means. And the m, that's your pattern slope. Okay, so that's the pattern slope. So we can check them with the start points. Easy to match if the start points are different. But what happens if all the start points are the same? Because if I look at all of these, guys way up here, I have a +4, a +4, and a +4. That means their start points are at the same spot. So if their start points are at the same spot, now I got to go to the slope pattern number. So, in order for the slope pattern number to look at, what do we do? Well, first thing we do here is we make the number into a fraction. Make the number into a fraction. Then, what do? We check the staircase. Staircase is the pattern. On the graph. So I'm going to show you what that means. I'll just give you a moment to write that down. Okay, so the first thing we're going to do, just like it says there, is we're going to put our fraction, or our slope into a fraction. Over 1. So if they're not in a fraction, you put a 1 on the bottom. Now that, remember, tells us how to move our dot. So we have our start point at +4 on the y. Okay? Now, is this line going up or down? It's an up line. We always read a graph from left to right, same as we do a book. So we would say, where on the left is it starting? It's starting down here, and it's rising to the right. Okay, so that's why it's an up graph. Well, up graphs only have positive numbers in front of x. Well, that means this guy with a negative number in front of x, he can't have that answer, because that line would be going down. So we know it's not A, okay, because that's a down line. And this graph's not going down. So now what we got to do is we got to figure out the pattern. So by figuring out the pattern on the graph, we do what's called making a right triangle, okay? But we want to make it with exact points. So I know I have an exact point with my y-intercept, and I see another exact point right there. So what I do is I make a triangle. And this tells me how far right and how far up he goes. So, making a triangle, I know that he went 2 to the right. There's 2 spaces there. And how far up did he travel? Up 4. Okay, does that make sense? So, how did I find the 4 spaces? Well, what I did was I counted, this guy started here because I found an exact point. And I counted as far right to the end of my triangle. That's how I got 2. Now I'm going to start where the base of my triangle is and count all the way up. That's 4. Okay, so now I know the base of my triangle is 4 and the height is, it's 2 and the height is 4. So, we've got this. What that tells me my rise over run. That tells me my slope. The one that goes up and down, that's the top number. So this number goes on the top, this number goes on the bottom of a fraction. So my slope number should look like this. Y equals 4 over 2x, and we know he starts at plus 4. Now, do we have to write 4 over 2? Is that how we would write that? Does that solve completely to an actual whole number answer? Yeah, you have to reduce it. You always reduce fractions if you can. So 4 divides by 2 evenly, and we get a 2. So the one that matches is this guy right here. So we get a 2 in front of the x. Okay, so letter C is the matching equation to that graph. Okay? Let's try a few more. So, example 2, top of the next page. Now we don't know how to match this one. We don't know how to match this one because the equation is not in y equals mx plus b. Does the equation look like it's solved for y?
No.
No, that equation is not solved for y. If it's not solved for y, we can't match it. We have to make sure we isolate the y variable if there's x and y. Okay, because remember, if they're x and y, they're diagonal line. Okay, diagonal disco. What is the new name for our diagonal lines? Oblique. Good. Okay, it's like a muscle we have. We have an oblique muscle. All right. So we've got this equation, x subtract 2y's equals a negative 4. So if I want to isolate the y variable, who has to leave and go to the other side? X does. X is on the wrong side this time. So we need to take this x over to visit the 4. And remember, the x gets written close to the equal sign, and the start point gets written after. Okay? Is it wrong if you write them backwards? No, it's not. As long as they have the same sign, either positive or negative, that matches. So, we have a positive 1 in front of that x. How do I move it to the other side? Subtract it. You got to make it a 0 pair. So 1 subtract 1 makes 0, and it disappears over here. So now I'm going to subtract 1x over here. Now when I do that, like I told you, this guy is going to go slide in front close to the equal sign, because that's where we like the x. We like him close to the equal sign. So now we've got negative 2y's equals negative 1x subtract 4. Now what do we have to do? We want the y by himself. Is he by himself yet? No. Back table, Sammy's table. One of you back there tell me, what do I do to the y number to get rid of something beside it? Something's being times to him. How would I get rid of them?
You divide the 2 out.
You're exactly right, Allie. We're going to divide out that negative 2 because it's being times to do the opposite. So we're going to divide out the negative 2. But if I do it to this side, I got to do it to the other side. So everything divides by the negative 2. So he divides by negative 2, and that guy divides by negative 2. And we always have to simplify. So when I simplify this now, that guy's all by himself. That's what we wanted. We wanted the y all by itself. Now what's a negative divided by a negative? A positive. So we're going to have a positive 1x over 2. And now over here I've got a 4 divided by 2. What's 4 divided by 2? 2. Now is it going to be a positive 2 or a negative 2? Positive, because I have 2 negatives. Good job, you guys. So plus 2. So now I've got my equation. I'll just write it up here. Y equals 1x over 2 plus 2. All right. Which one of these numbers, the 1/2 or the 2, is my start point? Hands up, put all out. Which one of those numbers, the 1/2 or the 2, is my start point? Taylor? The 2, good. Now, am I going to start way over here on 2, or am I going to start up here on 2? Which way do I start? Up and down or left and right? Up and down always. Okay, so we got a start point. Perfect. Now, how am I going to move my dot? What does this guy tell me? 2. Good. The bottom always moves right, so 2 to the right. What does the top do?
1 up.
1 up, because it's positive. So I'm going to go 2 right, 1 up. So I got to move my dot. 2 right, 1 up. Did I get that line? No. So let's move to the next one. Okay, start point at positive 2. Now I got to move myself. 2 right, 1 up. Did I hit the line? No. Let's try this guy. 2 right, 1 up. Ding, 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 ding. We found our answer. Okay? So we found letter C matches that equation. There's one more strategy you could do. You could also do this. You could substitute values in for x and y. So what you could do is find a point on each line. For example, this one right here has an exact point right there, has an exact point right there. You can take those exact points and put them in for x and y, and I'll show you. So if I use that one, that's at 1, 0. So here's the other strategy. If we didn't isolate the y variable, okay, so if we chose not to isolate y, we can put numbers in for the x and the y to see if they equal to the -4. So this is how we do left side equals right side. So we draw ourselves a t-chart, and now I would write the equation x minus 2y -4. It's got to equal to -4. So
8x.
what we're doing now is where the x is, we're going to put 1, and where the y is, we're going to put 0. So I've got a 1 where x is, and I've got a 0 where y is. And I want to see if I get a -4 for an answer. So what's anything times 0?
0.
0. So I have 1 subtract 0, which is 1. Is 1 equal to -4? No. That's why this line didn't match that guy's graph. Okay? So you could choose to do it this way. Did you see how long this one took? Way less steps. This one was way quicker to solve. So let's try the next one. We're going to do it the exact same way. So I'm going to do a left side, right side check. Come on now. There we go. So now I'm going to put the new numbers in. We got to find a point on this line. Here's an exact point. There's an exact point. I can use any of those exact points. There's another one. So I'm going to use the exact point of -1, 0. Okay, -1 and 0. So again, I've got x subtract 2y and a -4. So where the x is, I am putting a -1. -1. Subtract 2 times the y number, which is 0. Well, what's 0 times anything?
0.
0. Does -1 equal -4?
No.
No. So that's why the first two graphs didn't match our equation. Okay? Now, we're going to prove that this one does. So I'm going to grab a point off this graph. So let me just grab an equal point right there. Okay, so we're trying to find a point. If I count, this guy's 1, 2, 3, 4 over, 1, 2, 3, 4 up. So we found our point, 4, 4. And that's the one we're putting in the t-chart. So x minus 2y -4, we're using 4, 4. So I'm using my x numbers of 4 and my y numbers of 4. So what's -2 times 4? -8. What's 4 subtract 8? -4. Does -4 equal -4?
Yes.
Yes. So the left side equaled the right side here. So that's why this equation matches this graph. Okay? So if you find it difficult to isolate the variable y, all you need to do is do a left side, right side check and pick a point. And that'll tell you which one matches. Okay? So a couple different ways to do the questions. Let's take a look at another example. So here's the summary it's showing us. So these are the rules if I am not with you. They've got the steps here that shows you exactly what to do. Hopefully you wrote those other examples down as well. So if something is a solution, so if I say, is this number, like we just had on the last question, if I said to you, is 4, 4 a solution to that line, what would you tell me? Did the left side equal the right side? Then that means it's a solution, okay? So, left side equals right side, that means it's a true solution. Okay, and that's what they're telling us here, to be a true solution. The left side has to equal the right side, okay? All right, now, how do we determine the equation of a graph? Now, this is how we're going to write one, just by looking at the graph, okay? So moving on to the top of page 141. So, is it possible to find the slope of a graph? You bet. All we're going to do is draw a 90-degree triangle. That's what we're going to do. So we find two exact points and we make a 90-degree triangle. That's how we find our pattern number that goes in front of x. So we always start each question, y equals something x, and then the next blank is our start point. So what we call this is this. This one right here, that's our slope, or the pattern number. The pattern number gets a new name now. It's called slope. It gets a pretty fancy name. And then we've got our start point. And what's the fancy name for start point? Who remembers? Starts with a y. Y-intercept. Okay, that's his name, his real name. So I'm going to highlight the real names. Y-intercept and slope. Those are their real names. But we've been noticing we call them pattern numbers. Same thing. Pattern number is the guy in front of x. Start point, he's the y-intercept, meaning he's the guy that starts on that y line. Okay? Alright, so now we're going to go up to our graph, and we're going to find and make a triangle. So, find an exact dot. They're showing us this dot and this dot. So what we're going to do is we're going to make a triangle from those dots. There we go. There's our triangle. Now we need to count how many steps he went to the right. That's called the run, because it goes left and right. And the rise is the up-down. Okay? Alright, how many steps did he go to the right? You count them. 6 steps to the right. So you went 6 to the right. What about the rise? What did he do? Up 3. Okay, that tells us a couple things. So, remember, the guy that goes up and down, he's called the rise. And in the slope, this is the y number on top. That's why they say change in y. What was the change in the y number? Well, he went up 3. Well, we know that if it's up, that means it's positive. So we know that this guy right here is now positive. So he went up 3. So I'll put a 3 here. How many did he go to the right? 6. Nice. He went 6 to the right. Now, we need to find the start point. Here's our start point where he crosses on y. What digit is that? If you start in the middle, everybody start in the middle right here, and count how many spaces it is till you get to your start point. 2 spaces. He's a positive 2. I'm going from here to here. So the bottom, right to that point right there. He's 2 steps away. So that means he starts on positive 2. So that would be our equation. So we find the start point, we create our triangle, and we find our pattern number. Okay? Now, we always have to reduce every fraction. So what can I reduce 3 over 6 to become? 1/2, 1 over 2. So our real equation now is going to look like this. Y equals 1/2 x plus 2. There's our real equation. Okay? We're going to do another example on the bottom of the page. Now we're going to do a down line. Let's take a look what happens to a down line. All right, so here's our down line. Okay? So again, we need to create a triangle. But before we do that, are we able to find the start point? Are we able to find the start point? Remember, the start point's on this line right here. So I want to know where it starts. Well, where it starts is where it crosses that line. So, J-Berg, where does it cross?
At 0.
Right at 0, right in the middle. That's the origin. So, that means our start point equals 0. And that's what they're showing us right here, the b equals 0. Okay, so the start point is 0. So far from my equation, I know I've got this. Y equals something x, and then plus 0. Do I need to write the plus 0 there? No, but if you want to, if it's helpful for you, you can write it there. That means you start at 0. Okay? Please don't be messing with all that stuff back there, okay?
Sounds much.
Okay, well, you shouldn't be cleaning it with hand sanitizer.
Whoa.
So, you don't use hand sanitizer to do that. Okay, so far we have this. Now we need to make our triangle. Yeah. Okay, let's make our triangle. So I've got going over here and then up. There's a triangle. Okay, so how far, well, we're always going to move to the right, but how far would this guy have gone to the right if he started over here? That's 2 steps. Remember, the one that goes left and right is always a positive number. It's the guy going up or down that takes the negative. So this guy here, we would actually draw the triangle a little differently. We would actually do it this way. Boom, boom. So he goes 2 to the right, and then how far down does he go? 4 down. Okay, so 2 right, 4 down. So we're going 2 to the right. Whoopsie, wrong order. 2 to the right, 4 down. The negative sign means he's going down. So you need to draw that negative sign with that 4. Now remember, we always have to try and reduce that fraction. Will that fraction reduce? Yep, what does it become? Just -2. So now we're going to have y equals -2, x. You can put the plus 0 if you want to, but you don't have to. So that's our final equation. Okay? Final equation. All right. This is in that little section of notes you have. This is just notes on how to substitute into an equation. You guys have been doing this in your workbooks, but the notes in there were a little confusing, so I just wanted to make them a little bit more clear here. Okay? So what this is telling us is if they say, hey dudes, is this point on that line? How do we know? Well, what we're doing is substitution. We're putting the x number where the x is, the y number where the y is, and we're doing left side, right side check. That's all these are. If they ever say, is this point on a line? You're doing a left side, right side check. Okay? So this is left side, right side check. That's all we're doing. So I would make a T-chart. My left side has the y number, my right side has 3x plus 2. So now I'm going to put the numbers in where they go. The first one, I have x, then I have y. So my y number is a 4, my x is a 5. So 3 times 5 plus 2. Well, what's 3 times 5? 15. Well, what's 15 plus 2? 17. Does 4 equal 17? Heck no. 4 does not equal 17. So is that point on the line? No. No, it's not, because 4 is not equal to 17. So that's why. So you have to make sure you show the reason. No, because 4 is not equal to 17. Now we do another T-chart on 3 and 11. So now I'm going to come over here, make another T-chart. I got y and 3x plus 2. So now it says my y number is 11. My x number is 3. So 3 times 3 plus 2. How big is 3 times 3? 9. What's 9 plus 2?
11.
11. Does the left side equal the right side?
Yes.
Yes. So that means that this point right here is yes on the line. Okay? Because the left side equaled the right side when we checked it. Okay? So this is all we're doing is always left side, right side check. Now, there's a question you might see, and there are some on the quizzes, especially on the quiz this afternoon again. You're going to notice they're going to say, well, is this point for which equation would have these values? Okay? So that's the very last one on the bottom of that page 4. So that's this question. So it says, what's the pattern if A is 15 and M is 5? So which one of them matches? Well, in order to match, that means the left side has to equal the right side. And again, we're doing left side, right side check. So for each one of those, 1, 2, 3, 4, 5, we'll be doing left side, right side check. So I'm going to assign them to everybody. So what we're going to do is, we're going to have this group right here, this row, including Jenna, and you guys, you're going to do number 1. Okay? Charlie, in this row, you're going to do number 2. Back. You guys are doing number 3. Okay? You guys in the back table there, you're going to do number 4. You 4 are doing number 5. Okay? So what I mean is you're going to make your right side, left side chart. So if I was doing number 1, I'd have A plus 5 up here, and 3M plus 10 right there. Okay, I'll give you a couple minutes. Okay, all eyes up here. Hopefully you guys had a chance to go through this. Group A, did you get 20 wasn't equal to 25? Okay, perfect. So the first one did not match those numbers. Okay, so we can cross the first one off. Group 2, did you guys get it to match? Did it match? Left side, right side? No, it didn't match. What did you get for left side, right side?
15 and 20.
Right. You guys got what? 15 doesn't equal 20 on number 2. What about number 3? It didn't match. What did you get for left side, right side?
5 or 15 is equal to 5.
Okay, 15 doesn't equal 5, exactly. What about group 4? Does group 4 work?
No.
No, it doesn't. So, does group 5 work?
Yep.
Yeah, group 5 work. Okay, so again, you're just doing left side, right side check. Okay, yeah. Sure. So now we're just going to look at the workbook pages for a moment on this lesson. I want you to turn to the workbook page 143. This is from page 143, okay? I want to show you how we're going to match some of these questions. So when you're matching, okay, when you're matching and you're wanting to find out which one of these graphs is this graph, okay? Again, these ones are not isolated for Y. So this is where you pick a point, any point you want. Maybe pick the point right here. There's a point right there you can pick. There's a point right there you can pick. And this is where you do left side, right side. Okay? So for number 2, which one matches? So I'm going to pick the point right here, 2 and 0. Or sorry, 0, 2. So point 0, 2. So that's my X and my Y. So now I'm going to do it for all 3 of these equations. So I would go 2 times 0 plus 3 times 2 doesn't equal 6. So what's 2 times 0?
0.
0. Because this is right side, left side. So we get 0 plus, what's 3 times 2? 6. Does 6 equal 6?
Yes.
Yes. Okay, so this one worked technically. We have to see which other ones work. So far we know this guy worked out just fine. Now let's check it again. We have a negative here. So if I put a negative sign there, that's going to make this a negative 6. Does negative 6 equal 6?
No.
No. We found our matching equation already, but I just wanted to show you how the second one doesn't match. Okay, again, you're just doing right side, left side. Find a point on the graph and put it in for X and Y. Okay, let's look at a couple more. Down to number 3. Okay, number 3. Number 3 is also matching. So what it says is this. So it's saying from these guys, which of those three up top, it's saying which of these three graphs is going to match this equation. Well, remember, you got to do your start point and move your dot. If it's isolated for y, we have it isolated for y. We like those because they're easy to match. So our start point's at -1. We have to see if they start at -1. There's a -1, there's a -1, there's a -1. So they all have the same start point. Now I have to check and see how they move the dots. So make it into a fraction. This guy's going 1 right. Okay, and then it's going to go 2 down. Why 2 down? Because it's a negative sign. So we're going to go 1 right, 2 down, and see which graph I get to. So I'm going to try that on all three. So 1 right, 2 down. Nope, I didn't have nip on the line. 1 right, 2 down. Yeah, buddy. There we go. That's my graph. Okay? How do you know the graph is not the third one?
Because it's going positive.
Yeah, it's going up. This guy is an up graph, and we already know that we're looking for a down graph. So if this was multiple choice, you already have a 50-50 shot because you can erase this guy. Now it's between these two. Okay? So let the positive and negative help you. So right here, we don't have something to solve for y, but we can isolate y if we want. So I'm going to take y to the other side so it becomes positive. And then I'm going to take 3 to the left. So I'm going to subtract 3 and add y. So that's going to give me 3x plus, 3x minus 3 equals y. So now I've got my start point and I have my slope. What's the start point on that equation? -3. Good, it's the one without the variable. So I'm going to start at -3. There's -3. Uh-oh, they all start at -3. Nope, not all of them. This guy starts at +1. So it can't be that guy. Yep, you bet. So we already eliminated one of the graphs because we're looking for one that starts at -3. That guy over there starts at -1. So we eliminate that guy. Now again, we have a 50-50 shot. So we're going to make our slope into a fraction. This guy's going to go 1 right and then 3 up. So 1 right and 3 up. Well, if you look at our graphs, we've got a graph going down and a graph going up. Which graph should it be? The one going up. So it should be this guy. Okay? That's how you would match these questions. Okay, so I'm just showing you what you would do to make sure that you know how to do the questions. All right. Let's take a look at just a couple of these. So number 4. When you're looking at all of the questions and all of the graphs for number 4, again, what you want to do is you want to find the start point and how they move the dot. So this guy is our start point, and our slope is 1/1. You've got to make your slope into a fraction so you know how far right he's going to move. So 1 right, 1 up. Now we look at all the graphs. Well, it's a down graph, this is a down graph. We've got to look at some other graphs. We want a graph going up. Oh, there's a down graph. Here we've got a vertical. Here we've got an up graph and an up graph. Now, what number are we starting at? +3. This guy starts down in the negative, so is he a possible answer? No. This guy here starts at +3. Is that a possible answer? Yeah, let's check it out now. We have to check the slope. So we have to check and see if I go 1 right, 1 up. Do I hit the line? 1 right, 1 up. You bet I do. So we found that number 4 matches A. So I would go back now to here, and I'd say this guy matches number 4. Okay? So find the start point and move the dot. Now an easier way to do it, maybe you want to do it this way. Use each of the equations right away, just make the graph. So this guy starts at 0. He goes 1, 2, 3, 4, 3 to the right, and 1 down to get to the next point. So 3 right, 1 down. So I'm looking for an equation that looks like this. Something x is going -1 down, 3 right. So So you can also make the equation yourself and then find the equation that matches. Well, holy smokes, he matches letter E. So that's the first one, matches letter E. Okay? So I have a negative 1 over 3, here's my negative 1 over 3. Okay? Because he starts in the middle, right at plus 0. So you can say plus 0, but you don't need to put that at the end. Okay? This concludes lesson 4.4, matching linear equations to their graphs.